How's everyone? How did that test feel the other day? It felt real weird for me to not be here to give a test. Did that make y'all feel any different, or no? Same thing for you? Okay, I apologize that I didn't post the grades. I did grade them, and you will get them back today. But I will want to talk to you about the grades first of all. I find myself in a tough position here with this class. It's kind of turned into what I thought it would be when they said that we were going to condense 4 classes down to 3. We're going to have a huge disparity within the students of where people were, and I think the grades for this test reflect that more than the other tests had. So first of all, the class average on the test was 70. That's what that little X bar means. Sigma, which is a standard deviation, I believe I talked to you about standard deviation as a way to measure how close people are together in the class. Like, the class average was 70. Were a lot of people close to 70? Or did you have a bunch of high grades and a bunch of low grades that averaged out to 70, right? I said the smaller this number, the better. On the first 2 exams, the standard deviation was close to about 15, 16, somewhere around there. It was 26 on this exam, which means that there's a huge spread of grades. A's. On this test, we had 8 A's. And I believe of those 8 A's, there were 3 or 4 100s. All right. B's, we had 3 B's. C's, now C in this class is anything 75 and higher, right? There were no C's. D's, there was 1 D. And F's, which is anything below a 60, there was 11. So, I don't know. What do you make of this? I'll let you absorb that for a second. Oh, I know. Forgot my little laser today. Oh, well. So, that means that we had really 12 people not pass. And we had, 11 people pass. So I think for me, this is like the worst situation I can be in, because I have people who appear to understand the material, who are going to be prepared for the next class after this, so that they will succeed in the next class after that. And then I have a significant number of students that had trouble with this exam, which worries me about whether or not you'll be able to get through this course and the next one. You know, the next one's going to be as much, if not more, material than this, and then most of it will be new material. So I think it's time, as far as you individually, to take a look at your 3 exam grades. And if you're anywhere below a 70 at this point with those 3 grades together as an average, you need to come talk to me, because we need to start talking about options for you. All right? You don't want to just barely squeak by this class and go into the next class. It'll be a big challenge for you in the next class. So I think sometimes people get this idea that if I can just get through this class, I'll get to the next one. Well, sometimes it's better to go back and do a class again, and you be up in that group with the A's and B's. The second time through, you're up in that group, and then you're ready for that next level. Does that make sense? But I think that's something you'll have to take upon yourself to come in and talk to me about, all right? Like, if you turned in this exam and it had, like, every question you left basically blank, okay, there's issues here that we need to address, all right? But I'm not going to call you up or email you. I need you to reach out to me. I'll be willing to sit down with you and talk to you about what we can do, but you have to initiate that, please, all right? Okay, so let me hand these back so you don't sit there stressing out anymore. So the way I graded it, before I hand it back, the way I graded it is that there were 7 problems, so each problem was worth 10 points. So what you do is you just take, like let's say you got 10 points off, okay? Then what you do is you subtract 10 from 70, so that would be 60, and you divide by 70, and that would be your grade. That make sense? Okay. Try to mix these up. I don't even know if they were in any order, but all right, here we go. Kayla Gutierrez. What is it? Carla? Oh, I didn't see the R. It's very small. Okay, sorry. Lee? Samantha? Brittany? Brittany? Amber? Is Amber here? Oh, there you are, Amber, sorry. Priscilla? Hi. Alvaro? Davila? Marcus? Melanie? Vanessa? Jair? Cortez? Joey? Jessica? Susan? Let's see, Anthony Gonzalez? Shelby? Alexandra? Chandler? Erica? Okay, I'll let this Chandler. Linda? Alyssa? Alberto? Miss anybody? Everybody has it? All right. So, what to do now? What I'll do is I'm considering whether or not I should do test corrections or not. I think anybody who does plan to go to the next class, even if this test wasn't that great, and maybe your previous two were okay, but this one wasn't that great, I think that test corrections would be something I'd be open to. So my advice to you would be go through the test, make corrections, turn it in to me. All right? I'll figure out how I will factor that in and how it will affect your grade, but your job would be to go do that. Take the initiative, figure it out, find out where your errors were, and then turn it in. All right? And let's just say that'll be due next class. If you want to make test corrections, due next class. All right? So what do you think? I mean, I'm troubled. I kind of lost for words here. Do you think the test was fair? I mean, it was based on the review, right? You had a cheat sheet, so you were allowed to write down steps and procedures that help guide you through the test. So I'm just trying to figure out if there was something within the test that was the problem, or was it just the nature of the problems themselves? This is why it's so hard to talk to a class, because I know I've got people who got it and then people who don't. So, you know, if I ask the people who got it, they'll say, yeah, the test was fair, everything was great. And if people didn't, it might be a different sort of reply. So, all right, well, it doesn't look like I'm going to get much response out of you today. Let's try and do something. Let me see if I can connect here to the web. I want to see, or no one printed out the syllabus, right? No. Okay. I want to do something so that you know where you are kind of in the class right now. I'm going to pull up our syllabus. You do? Okay, great. Oh, there it is. Is it the whole thing? Let me see. I just want to see what the weights of the exams were on the syllabus. Thank you. I'll give this back. All right, what I'm going to do is I'm going to take a moment to help you figure out where you stand in the class, all right? Your lab is worth 5%. The quizzes that we take in this class are worth 15%. There's 4 exams. They're each worth 15%. And that leaves your final, right, at 20%. All right. All right, so let me show you how you can figure out what your grade is in the class. And basically whether or not you can still pass. I think because that's the most important thing for the people who might be struggling. Can I even pass the class anymore? So the lab, well, the lab is going to depend on you. Have you been going to lab? Have you been putting in the hours or not? So the way you can figure out your lab is just, if you know you haven't gone at all, that's a 0, right? If you've been going, you know you've got enough hours, give yourself 5, right? If you know you've gone about half the time, give yourself a 2 or a 3, something like that, right? So you have to do that. So I'm just going to act like I've gone every day and I've been keeping up. I would give myself 5. Now the quizzes are worth 15%, right? The way you can get your quiz average is you go on to our Canvas, you go to your grades, and at the end it'll have your quiz average. So let's say that my average on my quizzes was an 80, all right? Here's what I would do. I say plus 80 times 0.15, all right? Now my exams, plus, here's what I'm going to do. I'm going to take each of the 3 exams I have so far, right? My 3 exams are, I'm going to make up my own scores here. Let's say I have a 70, let's say I got a 60, and on this one I did a 50. I'm just making these up, all right? Then what I would do is I'd say plus 70 times 0.15 plus 60 times 0.15. That's times. I'll put it in parentheses. Plus 50 times 0.15. All right, now I'm going to get my calculator out, and I'm going to figure out what that is. Okay, so I do 5 plus 80 times 0.15 plus 70 times 0.15 plus 60 times 0.15 plus 50 times 0.15. So 44 is where I am. Okay, that's not my grade, all right, but that's what I would get if I add all those up. Y'all with me? Okay, now, if what I need to figure out is how many points are possible at this point. So the lab is five points, right? The quizzes are 15. And how many tests have you taken? 3 at 15% each, right? So 15, 15, and 15 adds up to be 45. If I add all those up, 45, 15, and 5, what do I get? Got 50, 65. So what I'm going to do is I'm going to take that 44 and I'm going to divide it by 65. And that would give me 0.677, something like that, which is about a 67%. 67, 68%. That's where I'd be. Okay? Now, that just tells you where you are right now. You have a 68 average, right? Any questions on that? Do you think you could do that on your own? Figure that out? Okay, now, what I'd like to do now is I'd like to figure out if it's even possible for me to pass. All right? So what I would do is look at, well, how many points are possible up to this point? 65, right? That's how many, that's the most you could possibly have. If you have hundreds on everything, you would have 65 points right now. 65 out of 65 would be 100. Does that make sense? All right, so how many points are left in the course? If 65, we've done 65 up to this point, how many points are left in the course? We have the final, and we have one more exam, right? So 35, do you all agree? There's only 35 points left. I have to get myself from a 44 to what's passing? 75? 75 is passing? So what's the difference between that? What do I get if I do 75 minus 44? I get 31. 75 minus 44 equals 31. How many points were possible? 35. Divide that by 35. Divided by 35, and you get 89, or 0.89. Which means what to you? Can you pass or not? If right now you do all this stuff with all your exams up top here, you come out with a 44, you know your grade right now in the class is a 68. In order to get a 75, I will have to get 31 out of the remaining 35 points in the class, which means I will have to hold an 89 average the rest of the way. I will have to get an 89 or higher on the final, on the next test, and then on the final, the same sort of thing. So 89 is what I need to average. Does that make sense or not? You have two more tests. That means you'd have to average an 89 on both. That means you can get 100 on one of them, and then maybe like an 82 on the other, but when you average them together, they have to be an 89. Am I making sense? Okay. So what I recommend you do is take a moment. If you're one of these students who haven't done well in the last few tests and you're concerned about your grade, try and do this on your own and figure out where you stand so that you know going ahead right now whether or not this is a doable thing or not for you. Right? Because what if this number at the end here, and if you need help with this, just come by my office. I'll help you figure this out. But what if that number out there, instead of 0.89, what if you get something like 0.94? That means you need a 94 average. And then you have to ask yourself, do I think I can average a 94 or not? That'll be something you'll have to answer on your own. Okay. Let's proceed with today's material. By the way, I need all these exams back because I did not have a chance to put them into the computer. So let's see, who came in didn't get their exam? Alberto? Was that you, Alberto? Here, you want to come up and take a look real quick? Albaro? You can look at it for a minute. Yes. Oh, yeah, you're supposed to do corrections. Well, okay, we'll keep them then. I'll let you keep them and turn them back in. But if you lose them, It's a 0, okay? Do not lose your exam. If you're not making corrections, you can just turn them in. Yep. If you don't want to, that's okay. All right. Yeah, you're not required to make corrections. Okay. Thank you. Something else I was curious to look at. Let me see if I can get onto the web or not. I wanted to see, we had our review, didn't we? Oh, that's our day of our review. So 20 views. I was curious how many views I would have on that video. So I guess some people did go and take a look at the review. Okay. All right, well, we have to move on, and that's what we're going to do now. So we are going to start a new chapter, which is probably, in some ways this could be good because the material from here on to the next test is relatively new. Not new, but different than what we've been doing. So if you've really been struggling with this whole concept of lines and, how do you graph a line and then these inequalities, if that's all just been confusing for you, well, there's a chance here that this stuff might be a little better because it's not that, okay? So chapter 5 is where we're going, chapter 5, and it's called Polynomials and Properties of what are called exponents. Now, here's what's happening, okay? In the big picture of things, right now, we should be able to handle lines, right? Linear equations in two variables. With x and y, I give you pretty much any equation with x and y in it, and you should be able to graph it. That's the expectation. Now, I know the tests don't reflect that necessarily, but that's the expectation. In college algebra, you are supposed to walk in there with a very, very solid foundation of lines. And then what you get into in college algebra is starting to study things that have x's and y's in them, but it's not linear anymore. So the graphs of these things aren't lines, they're something else. And they turn out to be something called polynomials. So like quadratics, I don't know if you've ever heard that before, quadratic like a parabola or cubic or something like that. All of these things fall into a category of called polynomials. So what we're going to do in here in chapter 5 is we're going to introduce the idea of what a polynomial is. We're going to start looking at the properties of polynomials so that when we work with them later in different classes, you'll be comfortable with, when your teacher does something, you're like, how in the hell did that happen? It's one of these properties that we're using, all right? So we want to make sure we're okay with these. All right, so the first thing is to come up with some sort of definition for, what a exponent and polynomial is. So we're actually going to start with the idea of what an exponent is. Okay, that's where we'll start. Exponents. All right, so we'll see how comfortable everyone is real quick. If I write 4 and then I write that 2 up there like that, what does that mean? 4 times 4? Y'all seen that before? Something like that? Okay, so yes, this indeed does mean 4 times 4. So the exponent here is the 2. That's what we call it, right? The exponent. And then the thing on the bottom, right here, anyone know what that's called? It's called the base. So you have a base and then you have an exponent. all the exponent does is tells you how many times you need to rewrite that base with multiplication between them. So exponents is repeated multiplication, right? Repeated multiplication. So if I write now 4 to the 5th, this means, oh yeah, sorry, what was 4 times 4 up there? I didn't do it. 16, right? So 4 with that little 2 as an exponent means 4 times 4, which is 16. 4 to the 5th, right, would mean how many 4s? 5 of them, all being multiplied, right? Not added, right? That's not addition between them. So to do that one, you probably need a calculator, wouldn't you? So I recommend that if you have a calculator, you start bringing it to class and you start getting comfortable with it, because every calculator is a little different, but they should all have a key on there that allows you to do 4 to the 5th. 4 raised to the 5th. Or you could just type in 4 times 4 times 4 times 4 times 4 like I just did, and you get 1024. So how would we say this in words if I was saying that to you? How do I say that? 4 to the 5th power. You don't have to say power, but, or you could say 4 raised to the 5th power, but you do not say 4 times 5, right? What is 4 times 5? 20, right? So the exponent gives us repeated multiplication. Now, in general, here's what we have. In general, if I take something like b and I raise it to the n, that means b times b times b. How many b's? B, that would be b raised to the n, right? N is how many you have, right? So I don't know what n is, do I? So what I would need to do here is put like dot, dot, dot on the bottom and then my last b. The dot, dot, dot means in the middle there, I don't really know how many b's there are. I just have some b's and then I stop at some point. And if you count all of these up, I should have n of these. N of these b's. Right? N of these b's there, lined up side by side. So that's the general definition. That's the way the book does it. I'm going to do a slight change to the book, all right? Because I think there's something important here that gets lost by students. What I'm going to do is, that's the formula that you see in the book. My formula is going to have the b in the parentheses. This means b times b times b times, and then I have a final b at the end. So my formula is very similar to theirs, except I use a parentheses. And you'll see why I like the parentheses in just a second as I do another example. So any questions up to this point? Okay, so let me now give you another example. What would -3 in parentheses to the 4th be? What does that mean? What does -3 raised to the 4th mean? I'm doing what? How many times? -3 4 times, right? So this means -3 times -3 times -3 times -3, doesn't it? Now you could get on your calculator and do this, or you could try and do it mentally. What's -3 times -3? +9. And then the last two, -3 and -3 together, +9 again. And what happens if you multiply +9 and +9 together? 81, right? Not 18, 81, because you're multiplying. So this should be 81, positive 81, right? Y'all see how that worked? Okay, now watch the difference between that and this. You get negative 81. Why? It all comes down to what's the base and what's the exponent here. The exponent in both of these problems is 4, isn't it? The base in the first problem is the entire negative 3. Now, the reason I know it's the entire negative 3 is because the negative 3 is in parentheses, right? On this second one, there's no parentheses, right? The 4 is only acting on one thing here, and that's the negative 3. It is not acting on the negative sign. The negative sign, I don't know if you remember this back from in the beginning of arithmetic for math, but a negative is the same as a negative 1, isn't it? So watch the way I write this below this so you can really see this. This is really negative 1 times 3 to the 4th. Do you see that that would be true? And then that 4, as you can see hopefully now, is really only acting on the 3, and the negative 1 is on the outside. So do you all remember order of operations? Please excuse my dear Aunt Sally. Did you all ever? PEMDAS? Yeah? Something like that? You always do what's in parentheses first, which we don't have parentheses. Then you do what? Exponents. So I'm supposed to do this operation first before I do anything with that negative 1, because that negative 1 in front of the 3 is really a multiplication, and multiplication comes after exponents. So I'm supposed to do 3 to the 4th first. 3 to the 4th means 3 times 3 times 3 times 3, which is 81. But what's still sitting in front of it? Negative 1. So I'm going to just write it this way. 3 times 3 times 3 times 3. So there's my exponent thing right there, and the negative 1 sitting out in front. So you get, at the end, negative 81. So there is a drastic difference between whether or not the parenthesis is there or not. If the parenthesis is there, then you use that negative within your multiplication like we did on the first one. If it's not there, it has to sit on the outside and wait for everything else to happen. Please do not be the one that gets confused on the test on that one, all right? No matter what, I'm going to give that problem, someone's going to get it wrong because for some reason it just always works that way. Maybe you'll be my first class that everybody gets that right when I put it on the test. How do you mean? Like, well, these are the two different ways the problem could be given to you. See, someone's going to write down what you need to figure out. If they write it down the first way, you put the negative 3, negative 3, negative 3, negative 3. If they write it down the second way, you do 3, 3, 3, 3, and then you bring the negative in. So it's all the way the problem is presented to you, parentheses or not. Am I answering your question or no? You sure? Okay. Let's look at something else. How about if we're trying to do 0.2 to the third? What does this mean? What is the exponent? Okay, what is the base? Just 0.2, right? Or 0.2, the whole thing. So because I don't have a negative here, I don't have to worry about the negative, right? If the negative's not there, you don't have to worry about is it in the parentheses or not. If it's just a positive number, then you just repeat the multiplication 3 times here. So I need to get on my calculator, and I need to do 0.2 times 0.2 times 0.2. Now I just put it in parentheses so that I didn't have a bunch of dots with decimal points and you get mixed up with what's a decimal, what's a dot. So what is that? 0.2 times 0.2 times 0.2. 0.0, so it'll be 0.008. This is kind of an interesting problem. I mean, not super interesting, but 0.2 is a fraction, right? A decimal. It's smaller than 1. Normally, you think that when you take a number and you raise it to a power, that the number gets bigger, right? Don't you normally think that? Like if I say take 4 and square it, it'll get bigger. If I take 4 and cube it, it gets bigger, right? 0.2, when I cube it, what happens to it? It becomes 0.008. 0.008 is very small. So this is an example of a number that when you raise it to a power, it actually gets smaller, not bigger. It's kind of an interesting thing to notice. Okay, what about this? -3/5 to the third. Okay, so look at my parentheses. The negative sign is in the parentheses, isn't it? That means that when I do the repeated multiplication 3 times, that negative needs to be in there with it the whole time. So what I need to calculate is what's -3/5 times -3/5 times -3/5. And now the negative also that I have out there, I put it up on the top with the 3. Do you all remember what we talked about when we talked about negative signs on fractions? It can be on the top or on the bottom or out in front. One of those 3 things. I'm just deciding to put the negative on all the tops. How do you multiply fractions? How do we add fractions? You have to get common denominator, right? Multiplication, though, is just straight across, isn't it? Yes? So let's go across the top. What's -3 times -3 times -3? Well, what's -3 times -3? +9, right? Times -3 again, -27. And then on the bottom, 5 times 5 is 25, times 5 again is 125. So your answer is -27/125. All right, I'd like to look at the next example. Next few, few examples are all going to look very similar. I'm going to have -7 squared. The next example next to that is going to be -7 squared. The next one is going to be -7 squared. So I gave you 3 examples. They all look similar. Let's see if you can figure out the differences between these answers. So how about the first one? -7 squared. -49. And that's because the negative that's out front is not attached to the 7, right? Because there's no parentheses. So I need to do the 7 squared first, which is 7 times 7, and then bring that negative as a -1 in front. So below this is really -1 times 7, which is -49. Are there questions on that? What about the next one? That's -7 times -7 because of the parentheses. So it'll be +49. What about the next one? We have talked about this before. I forgot my laser. It's kind of annoying today. We talked about before, whenever you see a negative and a negative, it always turns into a positive, doesn't it? But not here. Why? What's the order of operations? Parentheses first, then exponents, right? With this negative out here, this really is a -1 times a -7 squared. That's what that means. That negative means -1 times -7 squared. And because that now is multiplication between here and here, I have to wait. I have to do this first. So I have to do the -7 squared first. And what's -7 squared? That's this, right? Which is 49. But then what do you still have sitting out in front of it? A -1. So this one's going to be what? -49. Is that confusing enough for you? -49. Now, in general, minus a negative is always going to turn to a plus, but the fact that that 7 had the square on it changed things. Okay, now we're going to try something a little different. Evaluating expressions with exponents. First example. If a equals 2, find a cubed. Or let's make sure we understand what's being asked. And you know what? Let's put a 5 in front of it. 5a cubed instead. So what I'm telling you is a is equal to 2, okay, everyone? A is 2. So tell me what 5a cubed is. So what I'm going to do is I'm going to take my a, and I'm going to replace it with what? 2, all right? I'm going to replace that a with 2. Now, before I do that, let me ask you something. What is the exponent in this problem? 3. What is the base in this problem? A or 5a? What do you think? Is that 3 acting on the a by itself or the 5 and the a? Just the a? Why is it not acting on the 5? What do you think I would need if I wanted it to act on the 5? I would need parentheses. I would need to wrap the entire thing in parentheses like that. That expression with parentheses around it means that that 3 is acting on the whole thing. Without the parentheses, that 3 is only acting on the a. That is a critical thing in this class, that you understand how the parentheses work, all right, and what things are attached to what. So I'm going to highlight the 2 things that are attached here. That's the a is the base, and the 3 is the exponent. So let me rewrite now. I have 5. What's the operation between the 5 and the a? Multiplication, right? Times, now what's a? 2 to the 3rd power. Order of operations. What goes first? The exponents, right? 2 to the 3rd power. What's 2 to the 3rd power? It's 8, right? But this is really 5 times 2 times 2. I do these, right? That right there gave me an 8. So I have 5 times 8, which is 40. What are some of the mistakes that I see? People plug in they plug in 2 for a, right? And then what do you think they do? Multiply 5 times 2 and get what? 10? And then cube it. 10 times 10 times 10. They give me 1,000 as the answer. That's wrong. Okay? If A is equal to -2, find 5A cubed. Now, I haven't changed anything in the expression, have I? 5A cubed, exactly the same? So the exponent is still 3, and that's still only acting on what? The A, right? But look at the A I'm asking you to plug in. What's different about this A? It's negative, right? That is critical because when I write this to work this out, I write 5. The operation between the 5 and the A was multiplication. And then I'm going to put a -2 in here, right? And then I'm going to cube it. Do you think that that's correct to write it that way? Well, forget this is here, right? Forget the 5 is here. If the 5's not here, what's the exponent? What's the base right there? And the base is what? It would just be 2 if you write it this way, wouldn't it? Because the negative is part of the -2, isn't it? Up here? So when I plug it in, isn't the entire thing supposed to be cubed? So what am I missing here then? Parentheses. You have to wrap that -2 with parentheses when you plug it in there. That way, the 3 can act on the whole thing as opposed to just the 2. These are the little subtleties of algebra that you have to understand, have to get your head around, or else it just remains a constant headache. Exactly. When we are evaluating expressions, that means when we are plugging things in for letters, anytime we have a negative, always wrap it in parentheses. Because you're supposed to be plugging the whole thing in, right? And so whatever's happening to it needs to happen to the whole thing. So put it in parentheses. Now, -2 cubed means -2 times -2 times -2, right? What's -2 times -2 times -2? -8, right? So I have 5 times -8, which is -40. All right. All right, we're going to move to another example now. If, example. If A equals -3, find 4A squared plus 3A cubed. Let's first take a look at the expression. On the right side, I actually have 2 exponents in this problem, don't I? Okay, so let's look at the first exponent. It's a 2. That 2 is acting on what? The A and the A only, right? The 4 is not attached to that A. I mean, sorry, the exponent is not on that 4. It's just that. So those are the 2 things that are together there. Now on the other exponent is a what? A 3. What is that 3 acting on? The 3 and the A, right? Because the 3 and the A are wrapped in parentheses. So my base on the other one is 3A. Y'all see the difference between those? Okay, now what are we supposed to plug in for A? A -3, which means I need to wrap that -3 in what? Parentheses. Okay, so let me try and rewrite this whole thing. I have a 4. And then what's the operation here? The 4 next to the A squared means 4 times. So times, now what? Parentheses, -3. We say close parentheses, and then squared, right? Okay, I'm going to do that on the next step. All right, isn't this 4a squared with my a wrapped in parentheses because it's a negative? Now, plus, now, what? Plus parentheses, right? 3, what's the operation between the 3 and the a? Times, but what am I multiplying the 3 by? This 3 is times that a, right? So I need to put -3 right here, but I need to wrap it in parentheses. So I'm going to have another set of parentheses inside of a set of parentheses. So I have a -3 here. And then what? Big parentheses again, and then exponent cubed, or third power. See, parentheses aren't just for fun. We don't just throw them around and just, hey, yeah, throw parentheses there. It's great. That looks better. They are so important in math because if you just take a parentheses out somewhere, it can change the whole problem, right? Or the whole result can change. Or let's look at the first one. Order of operations. I need to square -3 first, right? Which means -3 times -3 because it's in parentheses. So this is really 4 times -3 times -3. What's -3 times -3? Positive 9. So this is 4 times 9, which is 36. Okay, I just worked that left side. I'm sorry, I can't scroll up anymore. I'll do this instead. Okay, look at the one on the right. What are we going to get here? Okay, so order of operations says parentheses first, right? So I need to resolve what's in here. See over here, parentheses first, -3, you can't do anything to -3, can you? -3 is just -3. But in this parentheses, you have these two numbers being multiplied. What's 3 times -3? -9? I forgot to plug in my... So I'm putting plus here. It's -9, and then what? Wouldn't it be what? But then to the third power, right? I'm going to do that on the next step. I'm trying to show you the difference between when you don't do these first, right? You did the exponent first, and then you put them together. Here, you put them together first, and then you're going to do the exponent later. And that's just because of the way the problem was written with parentheses. Now, what's -9 cubed? Well, that means -9 times -9 times -9, right? What is it? -729. Why is it a negative number? Because a negative times a negative times a negative should be negative, right? Negative times negative is positive, but then you multiply times another negative, you get negative. So -729. Now, we're supposed to take 36 and subtract 729, and this should give you negative 693. Questions? Okay, how about this? Find a to the second power, or we say a squared, b minus 2ab plus 2 AB squared minus B squared. If A is equal to -1 and B is equal to 3. Does that look like kind of a nightmare a little bit? It's a lot going on in there, right? A lot going on. All right, let's just focus on the first one here. A squared B. The exponent here is 2, right? It's acting on what? A, and that's it, right? The B is next to it. What's the operation between that A squared and the B? Multiplication, right? I'm talking about right here. That's multiplication in there, right? So I've got to figure out what A squared is first and then multiply times B. So let me write down the A squared. Well, A is a negative number, isn't it? It's -1. So I'm going to go -1 squared, but then times what? 3, right? Now, you can put the 3 in parentheses, but because it doesn't have an exponent, I don't necessarily need it. Now, if it was negative, I always say wrap it in parentheses if it's negative. Does everyone see that? I wrap the -1 in parentheses for my A, because I said always wrap negatives in parentheses when you plug them in, and then we're going to square it, and then we're going to do times 3. So we'll do that, but let's come back to it, all right? What's the next one? So I'm talking about, I'm doing -2AB right now. So I do -2. I don't have any exponents here, do I? So I'm plugging in A. A is what? -1. Should I wrap it or not? Yes. Then times the B, which is 3. So that's your second piece. Ooh. That's this one. This one was this one. Okay, next piece. Plus 2AB squared. What's the exponent there? 2, what is it acting on? The A and the B together, right? And the A and B together inside is multiplied together. So I should write plus 2, then look at my set of parentheses here. I'm just setting it up, okay? So what I'm doing is I'm saying, I know I've got to put something in here, and I know I've got to square it. So what's my A going to be? -1, should I wrap it? Yes. And then my B is 3 next to it, and I should put a dot between those because it's multiplied. So -1 here times a 3. That's this. And then the last part, minus B squared. Minus 3 squared. Do I need to put it in parentheses? Because B was not negative, I don't need to wrap it, okay? I can just put 3 squared, like that. Okay, everyone see the pieces? Let's try and do this first one. Order of operations, I do -1 squared. -1 squared means -1 times -1. What's -1 times -1? 1. 1 times 3 is 3. So that becomes 1 times 3, which will become 3. I'm moving down. I'm kind of doing that first one, and then let me do the next one. Now, this one's going to be a little tricky. We have, forget the minus sign for a second. We have 3 numbers, right? All being multiplied together, don't we? So let's just go from left to right. What's 2 times -1? -2 times 3, -6. But I had a negative out here, don't I? So I have minus a -6. I'm going to write that down so you can see it. This becomes minus a negative 6 when I put those three numbers together. But what is a minus minus? Plus, so plus 6. How about over here? What do I do first? Parentheses. In here, negative 1 times 3 is negative 3. And then you'll square it after that, won't you? So let me write that down. I have plus 2. Inside there becomes a negative 3. It's still in parentheses, then squared. What is negative 3 squared? This negative 3 squared means negative 3 times negative 3, doesn't it? Which is positive 9. What about the 2 and the negative 3? Should I put those together first? No, exponents go first, right? So this was a negative 9 next to a positive 2. Tell me if this is right. What's wrong with that? They're supposed to multiply, aren't they? This was multiplication. Right in here. Right there. That was multiplication, right? So when I write this next line, you either need to put a dot there or put it in parentheses like that. The parentheses imply that you're going to multiply these together. So this times this will give us what? Negative 18? Okay. So 3 plus 6 minus 8, yes? Yeah, why did we put negative 9? Thought we said positive 9, didn't we? I'm going to have to go back and look at the video. I'm glad you pointed that out. Why did we put negative 9 here? That's positive 9, right? Did you all sit there and scratch your head? Whoever's okay, I'm glad someone finally spoke up. Negative 3 times negative 3 is positive 9. And then 2 times 9 is 18. Yes. It's Monday, yeah. I'll be real honest. You know why I made that mistake? I'll tell you why I made that mistake. Because I'm paying attention to who's sleeping, who's like not paying attention, like falling asleep in this class. And that distracts me. Okay? That distracts me. So when I'm sitting here trying to talk to my class and I look out there and there's people sitting there all chilled out, not paying attention, or maybe paying attention but just like kind of dozing off, that distracts me. I'm not making an excuse. That's the truth. That's what I'm thinking about. Okay, so now, last term, right here. This one's going to be tricky maybe. I don't know. Let's see if that trips you up or not. We decided not to wrap the 3, right, because it wasn't a negative. So with that expression, what's the exponent working on? Just the 3, right? The negative in front's like a negative 1. So I should square the 3. What's 3 squared? That's 3 times 3. That's 9, but it has a minus in front of it, right? So it'll be minus 9 here. Or you could say negative 1 times 9, which is negative 9. And then we have to put all these things together, and that'll be our final result. Hey, it's nothing, right? Is that 0? No, it's not. It's close. 3 and 6, 9, right? Plus 18, minus 9, 18. So our answer is 18. Okay, we don't have time to move into the next part of this section. I went really slow through this. We still have a lot to do here. So what I'm going to do now is I'm going to give you an in-class, let me just give you 3 problems, or 2 problems, just to see if you understand this or not. See if you can do this, all right? Let's turn these in. Yeah, we'll use it as a quiz. Problem number 1. If A equals -4 and B equals 5, find -4B squared plus 3AB squared. 2, if A equals -2 and B equals -1, find -4A squared B plus 3A squared B squared. So these are a bit of a challenge. We'll see how you do with them. And I'll put your homework on the side. You can work together. Page 349. Let's see. So that's your homework. Page 349, number 27, and then 39 through 61 odd.